Hey folks, and welcome back. Today we're going to be talking about valence electrons and dot diagrams, building on what we were talking about with the periodic table, and hopefully understanding a little bit more of kind of the valence electron thing, which we mentioned in the periodic table notes. So remember that all of the A group elements in a group have the same number of valence electrons. Okay, that was something that we said before, right? So all the alkali metals, all the alkaline earth metals, halogens, noble gases, they all have the same number of valence electrons. So the question is, what the heck are valence electrons? Well, these are electrons that are found in the outermost energy shell. Okay, so we're only talking about the ones that are in the outer energy shell here. Okay, so if we're taking a look at boron, right, we're ignoring the 2 electrons that are in the first energy level and just looking at the 3 that are in the outer energy level. Therefore, we would say that it has 3 valence electrons. For silicon, we're going to be ignoring the 10 electrons in the the first and second energy levels and just looking at the 4 that are in the outermost level. So therefore, we would say that it has 4 valence electrons. And then antimony, right, we're ignoring all of these electrons that are in the first set of energy levels and shells, and we're just looking at the electrons that are in the outermost energy level, which gives us 5 valence electrons. And valence electrons are very important because they help to determine how reactive an element is and what it will react with, which is something that we're going to be getting into in our next unit. So it's very important that we understand valence electrons and where they're coming from. And then also we're going to be talking about how do we kind of show the valence electrons, because this is kind of a wonky way of doing this, right? We don't necessarily need to worry about all those other electrons in the nucleus, right? These are kind of our Bohr models here. What we're going to be doing is we're going to be taking a look at how can we draw a more simplified version of this. Now, how do we actually determine the number of valence electrons using the periodic table? Remember, we said that every group in the periodic table has the same number of valence electrons, and so we can basically use that in order to be able to figure this out pretty easily, okay? So group 1A, right, for all the A groups, the 1, right, the 1 here, that is going to tell you your number of valence electrons. So 1A is 1 valence electron, 2A, 2 valence electrons. We're going to skip the B group elements, and that's because they have different numbers of valence electrons, and it has nothing to do with which group they're in. There's no pattern or anything like that. So that's the reason why those transition metals, they are really weird. We talked about how the rules are different for them, so we're just going to totally ignore them. We're just focusing on the A group elements. So we skip all the way over to group 3A. That's 3, 4, 5, 6, 7, and then 8A. So notice that there's a pattern, right? 1, 2, 3, 4, 5, 6, 7, 8. Pretty straightforward. You just have to remember that this only counts for the A group, okay? Just for the A group. Now, the one exception to this is helium, okay? And remember, that's because the first energy shell, the first energy level, can only hold 2 electrons, okay? And so helium has just 2 electrons, and so those are both of the electrons that are in the outermost energy level, and so that they would go right there. That's why helium would it be 2 and instead of 8 like the rest of the noble gases, but all the rest of its properties are like the noble gases, which is the reason why it is located there on the periodic table. So it's the one exception that you have to remember. Now, my recommendation is that you go back to the periodic table from our last set of notes, right, where you drew all those things. And my recommendation is at the top of each of the groups, you write how many valence electrons it has, right? So write that it's 1 valence electron for group 1A, 2 valence electrons for 2A, 3, 4, so on and so forth. That way, you have it written down on that periodic table. We're going to keep adding more things to that periodic table, so that way you have one place to be able to go to be able to look up this kind of stuff. Okay, so that's how we determine our number of valence electrons. We have to look at the A group number. Now, again, like I kind of mentioned before, drawing these Bohr models, right, is kind of a chore in order to be able to visualize the number of valence electrons. And so what scientists have done is they've simplified this and they draw what are called dot diagrams, or sometimes called Lewis structures, okay? And that's because, again, valence electrons are super important, right? We draw these special structures. And so dot diagrams are basically simplified Bohr models where we just have the symbol of the element plus the number of valence electrons. So for example, lithium, right, is in group 1A. It has one valence electron. So here is the symbol Li with one dot. Nitrogen in group 5A, right, has 5 dots representing those 5 valence electrons. So how do we actually go about drawing dot diagrams? Well, we write the element symbol first. Then we determine the number of valence electrons using the periodic table. Then we draw the dots representing those valence electrons in pairs around the symbol until you run out. And the number of dots should never exceed 8 because you can't have more than 8 valence electrons. So let's take a look at a couple examples. And hopefully you've been taking notes here in the assignment for today. Basically changed it up. We're now going to do notes and the practice on the same sheet. That way it's all in Cami. And what we're going to be doing is we want to draw some examples. So we'll come down here to this last box, and we said strontium and selenium. So strontium on the periodic table is S. That is not the drawing one. All right. So strontium on the periodic table is Sr. Okay, and selenium on the periodic table is Se. So let's go to our periodic table. Here is strontium, number 38. It is in group 2A, which means that it's going to be having 2 valence electrons. So we're going to draw our first valence electron here, and then we'll draw our second valence electron here. And that's all there is to it, right? That's strontium drawn correctly. Selenium, let's go to the periodic table again. Selenium, blah, 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 blah. Over here on the right-hand side of the periodic table, number 34. We go up. It is in group 6A, right? Vi, that is 6, so that means that it's going to be having 6 valence electrons. So that is 1, 2, 3, 4, and this is where we start pairing things off, 5 and 6, okay? So that is the way that we are drawing our valence electrons for selenium. Okay, so what you're going to do now is you're going to practice. You're going to be drawing the Lewis structures or dot diagrams for all of the first set of the elements. Okay, so make sure that you're following the rules that we just laid out. There's a reminder right here of how to do that, right? And then you can kind of see the pattern here for how you're going to lay out the dots. Okay, so you start here 1, 2, 3, 4, and then you start pairing them off as you come back around 5, 6, 7, 8. Now remember, helium is a little different, so don't forget about helium. Make sure you're doing that one correctly. Okay, so make sure you complete this and submit it, and I'll talk to you all soon.